Hi everyone, welcome to the video. In this video, we'll talk about taints, tolerations, and node affinity. We'll look what these things are, when are they used, when are taints and tolerations used, and when are the node affinity used, and when they are used combined together. We'll also look into some hands-on about taints, tolerations, and node affinity as well. So let's get started. So firstly, let's start with what taints are. So taint basically in English, it means that it is a word or it is a title that remains with a person for rest of his life or her life. Basically, if a politician is corrupt, then he or she will be tainted to be corrupt for rest of their life. So in Kubernetes, taints are applied to the nodes so that nodes can decide which pod they want to take in and which pod they do not want to take in. Basically, which pod will be part of that node and which pod cannot be part of that node. So how this basically works is we'll apply a taint to a node. For example, the taint would be, let us say, GPU is equals to true. And now only the pods which have the toleration for this GPU is equals to true will be allowed to be part of this taint. So this is what taints and tolerations are. We'll learn more about it later. For now, let's move on to node affinity because they are quite similar concepts. So here we talked about taints as from the nodes perspective, that nodes are picky about which pod to choose. With node affinity, pods decide which node they want to be scheduled in. So let me give you an analogy for this. Consider nodes and pods to be candidates and companies. So pods are these candidates which want to get in to these companies, and companies are hiring. So if companies, let us say companies are hiring for, there are two companies, company A and company B. Company A is hiring for DevOps as a DevOps engineer, and the company B is hiring for an SWE. Company A and company B, what they will do is company A will set a taint that we want a DevOps engineer, and company B will set a taint that we want an SWE. And all these pods now have to have tolerations. So now the pod or these candidates will have tolerations either for the DevOps role or for the SWE role. Depending on that, they'll apply to these pods. They'll apply to these nodes. If a pod has toleration for DevOps engineer, then they will apply to company A. If they have toleration for SWE, they'll apply to B. Now, this was from the perspective of the company. There is also a perspective of the candidates, right? So, from the perspective of candidates, we have this node affinity. So, what node affinity says is that every candidate also has some criteria. Like some candidates would want a job that pays them like 20 lakhs per annum. Some would want 10 lakhs per annum. Some would want 6 lakhs per annum. So now these candidates will also decide which companies they will apply to, which companies are allowed to have them basically. So, for example, candidate A would say, I want 20 LPA at least. So he will only apply to jobs or she will only apply to jobs with more than 20 LPA. And now the pods and now the companies, the nodes have to also match that label basically, that okay, we are paying more than 20 LPA. For example, company A pays more than 20 LPA, only company A can take the candidate A now. In the same way, node affinity works, where taints are from the nodes. Taints decide for the node that okay, this pod is allowed in the node and this pod is not allowed in the node. Similarly, node affinity lets the pod take control and let the pod decide which node they can be part of. So now pod has these uh, affinity rules, and all the nodes which satisfy these affinity rules are allowed to schedule the pod. So this is the basic idea. We'll talk about both of these in detail. Now let's come back to taints. So we talked about the definition here, and then there are these effects. So let's do hands-on. I think it will be easier to understand when we do it practically. So now I am at my Ubuntu terminal. Let me show you the nodes that I am running. kubectl get nodes. So currently I have three worker nodes, worker, worker 2 and worker 3 and one control plane. Now what we will do is we will first taint this worker and then we will apply toleration to a pod. So let us taint it. How we do that is kubectl taint. We have a not train taint. This command is used for tainting or applying taint to a node. So we'll use this kubectl taint node, name of node, and then the taint. So this will be like key is equals to value and there is one effect. So for now we are keeping key as key 1. Let's call value as value 1 and let's say effect to be no schedule. We'll talk about these effects later, but for now you can just think of it as there is one effect added to it. So it says that taint is not applied because there is already a taint present. So maybe I forgot to remove the taint. Firstly, let me remove the taint. Also, you'll learn how to remove the taint as well. So to remove the taint, the command is exactly the same. And at the end, you just have to add a hyphen. So now it has been untainted. Now we'll taint it again, which is this command. So now it is tainted. Now we will describe this node and we will grab the taint. So we can see that we have applied this taint to the node. Let me do one thing here. Let me apply taint to every worker node and see what happens when we try to use a pod without applying any tolerations there. So what we will do is we'll apply this taint again to worker 2 and then we'll apply this to worker 3. So now all these nodes are tainted. Basically, nodes have decided that only when the pods will have this toleration, only then they are allowed to be part of these nodes. So no node will be accepting any pod without this toleration. So let's create a node here, not a node. Let's create a pod here. Nginx image would be Nginx. That's it. And the pod is created. But when we check the list of pods, we will see that it is in pending state. Why? Let us describe it. This is because 0 out of 4 pods are available. Why? Because the control plane has a default taint, that the control plane node would have a default taint of this, and then the other three nodes have this taint of key 1 is equals to value 1. Therefore, this pod cannot be applied. Now what we will do is we'll create a pod which has these toleration for the state and let's see what happens. Let me clear this. Let me create a pod.yaml. Okay, let's get the template for the pod using kubectl run. So we want it to be called nginx. We want the image to be nginx and we would want it to be try run is equals to client. Output should be YAML and let's give it to the pod.yaml. Pet pod.yaml. We have this pod.yaml. Let's see. So this is how it looks. At the same level with containers, we will add our tolerations. How we do that is tolerations. It is a list. So key will be what? Key 1 and the value will be before value there is operator. So operator basically is equal here and then value would be value 1. Effect, as we defined there, was no schedule. No schedule. I'm not sure if we call it schedule or schedule. I think it is schedule. No schedule. I'm not sure. Is it schedule? It is called scheduler, so it should be schedule. I'm confused about it. I'll call it schedule for now. And we have the toleration. I hope I have not made any indentation mistake. Let us apply it. It gives us some warning. Let's ignore it for now. But the pod.nginx has been configured. Now, if we see, the nginx is in running state. Earlier it was not, but now it is because we have added the toleration for those taints. So now that we know what taints are and how they work, let us also get some knowledge about the effects. Now I think it's easier to understand these effects. So first is no schedule, that one, the one which we used. So no schedule basically says that do not add any pods that will not have these toleration for the taint. So any new pod that is coming, only if it has the toleration, only then it can be added. But the existing pod are fine. Do not remove the existing pod. For example, if the node has pod A, which is already present, and pod B. The pod A and pod B, none of them have the tolerations for the taint that the node has. But no schedule basically says if pod A is already running, then leave it. The new coming pod is pod B. Only check tolerations to pod B. And if it does not have the tolerations, then don't allow it. But the existing pod are fine. Do not do anything with it. But if we say no execute will not only check the coming pods, but it will also check the existing pods. If they do not have the toleration, then they will be removed from the node. And then there is prefer no schedule. So this basically means there is no strict enforcement. If there are new pods coming, do not add pods that cannot tolerate the taint, but there is no strict enforcement here. Now let's come back to node affinity. We talked about node affinity, the theory part. These has two types: required during scheduling and preferred during scheduling. So this is actually the syntax: required during scheduling, ignored during execution. Why are we calling it this way? Because node affinity does not work on pods that are already running. Unlike what we saw at the taints, let me show you the differences. So for taints and tolerations, basically, if there is an existing pod, it may be impacted if we are using the if we are using no execute. But for node affinity, they do not work on the existing pods. They never work on the existing pod. Only coming pods are uh, checked, or only the coming pods are worked upon. You will ignore the existing pod with node affinity. So what the required during scheduling, ignored during execution means is that pod will be scheduled to nodes that have the matching rules. If they do not have the matching rules, they will not be scheduled. But the other one, preferred during scheduling, ignored during execution. This means that pods will definitely check for the matching rules on the nodes. But for example, no node has the matching affinity rules as the pod, then it will be scheduled to any of the nodes. So this one is strict enforcement, where if you do not have a node which matches to the pod's rules, then the pod will not be scheduled. But the preferred one says that yes, the it is preferred to have the matching rules in the nodes, but if none of the nodes have the matching rules, then pod will still be scheduled. And like we said that unlike taints, node affinity does not impact the running pods. It will only impact the coming pods. Now let's go back to our terminal and let's do a hands-on on the node affinity as well. Before doing that, firstly let me clear this and let me remove the taint from all the nodes. So I'll simply find the taint command and I'll add hyphen. Node 3, worker 3 has been tainted, untainted. Worker 2 has been untainted. We'll do the same for worker as well. So now all nodes, worker nodes have been untainted. The control pane is still tainted. Let me clear this. Now what we will do is we will add labels to these nodes. For that there is command called label. Let me take some help. So first is kubectl. First is type is nodes, and then there is name. Name of the node was, I'll have to check again. Let's say worker. So kubectl label node, name of the node, and then key value. Let's keep it the same. Key1 is equals to value1 is equals to value1. So it has been labeled now. Let's clear this and I'll need a new pod. So I'll simply take the pod YAML and I'll paste it to another pod, pod 2. Let's go to pod 2 and let's change the name, nginx2. Let's remove the tolerations. And like the taints are applied at the same level as containers, the node affinity is also applied at the same level as the containers. But the syntax is quite different than the taints and it is much more difficult to remember. So for that, we will simply go to the Kubernetes documentation and we'll search for node affinity here. Go to the first link and we'll try to find a node affinity. Let's copy this. So this is how the node affinity looks like. We have given affinity and then we have said node affinity. Then we have chosen the type to be required. And then we have the selector terms, which are basically the affinity rules. So now we are designing the rules. Let us change the key. Key should be key1. Operator, let it be in. And values, let's call it value1. I think now it is fine. Let us do one more thing. Let us remove the label. Because if we have a label, the pod will be assigned to the node of that label. So let us remove label so that the pod is not assigned to any label so that we can check if the pod is not assigned to any label. So let us remove the label, label node. I don't remember the node name again. So first we have to do get nodes, copy the name, kubectl label, node, name of node. And to remove the label, we simply have to type the key name and a hyphen. So it is now unlabeled. So now let us apply the pod. The pod is created. Let us see. I'm sure it will not work. So it is in pending state. Let us check why is it in pending state. We can see that it says 0 out of 4 pods are available because one pod has this is because one pod or one node has a untolerated taint, which is for the control plane, and then other three nodes do not have the labels, so they do not match the nodes, the pod's node affinity, which basically means that these nodes do not match to the affinity rules that we have set in the pod. So now let's add that label to the nodes. So for that we'll say kubectl label. Let us copy the command. So we'll say key1 is equals to value1. Now when we will say kubectl get pods, again both are running. So this is because now the pod has found a node which can satisfy its affinity rules. So this was worker 1. So if we check the, okay, we can simply check it here. If we check the node to which it is assigned, to which this pod is assigned, we will see that it is the worker node. Why? Because only this node satisfies or matches the pod affinity. So only this node is available for the pod to be assigned. So this is basically how the taints and tolerations work. I hope you were able to understand how what taints are, what tolerations are, what node affinities are, and how they are different from one another. Let us also have a look at the differences between them. So these are the differences between taints and toleration versus the node affinity. So these taints and tolerations basically work from the direction of the node towards the pod. So basically here the node is picky about which pod it can take in. Whereas the node affinity is basically from the pod to the node. So here pod is picky about which node it should be part of. So here the node decides, okay, I want these pod and I do not want these pod. Whereas with node affinity, the pod decides, okay, I want to go inside this node or I want to go inside that node. The second point is it uses used to keep the pods away from the nodes. The same thing that we said. The pods uh, that are not able to tolerate the taint will not be assigned that node. Similarly, here also, only the nodes that have the same affinity rules as the pods will be used or will be given the pod. The third point is basically that it is mandatory if the node has a taint and the pod does not match the toleration, then it will not work. But here we can have a preferred or a required type, like we said. So for the required type, it is mandatory, but for preferred, it is preferred to get that particular type of node. But if the cluster does not have that node, then the pod will be assigned to some other node. And the final point basically says that we use taints here and we use tolerations in the manifest for applying taints and tolerations. And for node affinity, we use labels for the node, and for the YAML manifest of the pod, we use this affinity field. So this is it about taints, tolerations, and node affinity. These are basically used for the for the pods and the nodes to decide upon each other, basically, that which node should be which pod should be part of which node, and which node wants to take in which type of pods. I hope you understood what taints are, what tolerations are, and what node affinity are. And I hope you also performed the hands-on because it was easier to understand both these concepts using the hands-on. And I hope this video helped you. Thank you for watching, and I'll see you in the next one.